Dear student, you have learnt how to factorize the given polynomial by splitting the middle term in the previous video. So today we shall learn how to factorize the given polynomial by factor theorem, by applying factor theorem. Now we are going to factorize the given polynomials of exercise 4.4 of chapter Polynomials of class 9 mathematics. So this is the first problem, 12x square minus 7x plus 1. This is a polynomial. Now let us take the common factor of this polynomial. So I am going to take 12 outside. So you may ask why I am taking the common factor outside. The purpose of taking common factor is to get the simplified polynomial which matches with the given standard identity. So if we are able to match it with the standard identity, we can find the zeros of the factors. Zeros of the factors of the given polynomial. So that's the purpose why we are taking the common factor outside. Let me take 12 outside and write the remaining terms within the bracket. So first term is x square minus 7 over 12x plus 1 over 12. Close the bracket. Now let us check whether they are correct or not. 12 into x square, 12x square. Plus into minus, minus. 12 into 7 over 12x is minus 7x because 12 in the numerator and 12 in the denominator get cancelled by division method. 12 ones are 12 ones are. You will get minus 7x. Then 12 into 1 by or 1 over 12 will get 1 because 12 in the numerator and 12 in the denominator get cancelled. You will get 1. So let it be equal to 12 into px, where px is a polynomial. If a and b are zeros of p of x, that is polynomial, then the factors of the given polynomial are x minus a and x minus b. Observe keenly here, when we have plus sign, here it becomes minus. When you have plus sign here, it becomes minus. So you can see the change in the sign in the factors. Now 12 into x square minus 7 over 12x plus 1 by 12 is equal to 12 times x minus a into x minus b. Now let us remove 12 on the both sides. We'll get x square minus 7 over 12x plus 1 over 12 equal to x minus a into x minus b. Now let us compare with the standard identity. X square minus a plus b into x plus ab is equal to x minus a into x minus b. Now minus a plus b equal to minus 7 over 12. This here minus minus get cancelled. Therefore a plus b is equal to 7 over 12. Last term we have product ab, that is equal to 1 over 12. So by close observation, that is by inspection, so we get a is equal to 1 over 4 and b is equal to 1 over 3. Now by inspection we have got the value of a and b. So we have to check whether they are correct or not. So upon adding these two, we have to get 7 over 12. Upon multiplying a and b, we should get 1 over 12. Let us verify. A plus b is equal to 1 over 4 plus 1 over 3. So LCM of 4 and 3 is 12. Now divide LCM 12 by denominator of first fraction. We will get for 3 times 12, 3 as the quotient. Multiply the numerator of first fraction with the quotient, that is 3. 1 into 3, put it in the bracket. Then we have plus sign, you write plus. Then again multiply the LCM 12 by the denominator of the second fraction, that is 3. So we will get 4 as the quotient, 3 4 times 12. So multiply the numerator of the second fraction by the quotient, that is 4. 1 into 4, put it in the bracket. 1 into 3 is 3, plus is here. 1 into 4 is 4 over 12, 7 over 12. So a plus b is equal to 7 over 12. Now AB product is nothing but a into b. What is the value of a? 1 over 4 into 1 over 3. 1 into 1 is 1. 4 into 3 is 12. AB is equal to 1 over 12. So a plus b is equal to 7 over 12. Here also a plus b is equal to 7 over 12. AB is equal to 1 over 12. Here AB is equal to 1 over 12. So that means the value of a and b are correct. So let us find the remainders for zeros, that is a is equal to 1 over 4 and b is equal to 1 over 3 of the factors x minus a and x minus b. So we have to find the zeros for the, we have to find the remainders for the zeros. A is equal to 1 over 4 and b is equal to 1 over 3 of factors x minus a and x minus b. Let me turn the page. Now we know that the polynomial p of x is equal to x square minus 7 over 12x plus 1 over 12. Now let us find the remainder for the first zero, that is 1 over 4. Now substitute 1 over 4 in the place of x in the given polynomial. So 1 over 4 whole square minus 7 over 12 into 1 by 4 plus 1 over 12. Now 1 into 1 is 1, 4 into 4 is 16 minus 7 into 1 is 7, 12 into 4 48 plus 1 over 12. Let us find the, we are simplifying the fraction, let us find the LCM of the denominator 16, 48 and 12. 16, 48 and 12 are divisible by common number 4. Let us divide them. 4 times 16, 12 times 48, 3 times 12. Here in the second step, all the three numbers are not divisible by common number, only the first and second number are divisible by 4. Let us divide 4 and 12 by 4. 4 1 times 4, 3 times 12 and 3 as it is you write, because 3 is not divisible by 4. Again 1 is not divisible by 3, but 3 and 3 are divisible by 3. So let us divide 3 and 3 by 3. 3 here 1 as it is, 3 1 times and 3 1 times. Now LCM is equal to, you have to multiply the common numbers 4, 4 and 3. 4, 4 and 3. 4, 4 the 16, 16, 3 is the 48. So 48 is the LCM. You write below the fractional line. Now divide 48 by the denominator of the first fractions, that is 16. When we divide 48 by 16, we will get 3 as the quotient. Now multiply numerator of the first fraction by the denominator by the quotient, that is 3. So put it in the bracket, 1 into 3. Then you have a minus here. Now again multiply LCM 48 by the denominator of the second fraction, that is 48. When we divide 48 by 48, we will get 1 as the quotient. Now multiply the numerator of the second fraction by the quotient we have just obtained, that is 1. So 7 into 1, put it in the bracket. Then we have plus here. Again divide 48 by the denominator third fraction, we will get 4 as the quotient. Multiply the numerator of third fraction by the quotient here, 4. 1 into 4, put it in the bracket. Now let us simplify. 1 into 3 is 3 minus 7 into 1 is 7. Then 1 into 4 is 4. 3 minus 7 is minus 4 and you have plus 4 here. Whole divided by 48. Minus 4 plus 4 get cancelled, you will get 0. Then denominator you have 48. 0 divided by 48 is 0. So remainder is equal to 0. So you know that if the remainder is 0, then x minus 1 1 over 4 becomes the factor of the given polynomial. So here x minus 1 by 4 is the first factor of x square minus 7 over 12x plus 1 over 12 by factor theorem. So let us find the remainder for the second zero, that is 1 over 3. P of 1 over 3 equal to, now substitute x by 1 over 3. So 1 over 3 whole square minus 7 over 12 into 1 over 3 plus 1 over 12. Now remainder is equal to, again I repeat, P of 1 over 3 is equal to 1 over 3 whole square minus 7 over 12 into 1 over 3 plus 1 over 12. Now 1 into 1, 1, 3 into 3, 9, minus 7 into 1, 7, 12 into 3, 36, plus 1 over 12. So let us find the LCM for the denominators 9, 36 and 12. 3 times 9, 12 times 36, 4 times 12. Again divide 3, 12 and 14 by 3. But 3 1 times 3, 4 times 12. We cannot divide 4 by 3, right, as it is. Again divide by 4. We cannot divide 1 by 4, right, as it is. 4 1 times, 4 1 times. Now multiply 3, 3 and 4. So 3 3 is 9, 9 4 times 36. Now put a fractional line below that, write the LCM 36. Now divide the LCM by the denominator first fraction. Denominator first fraction is 9. So when you divide 36 by 9, you will get 4 as the quotient. Multiply the numerator first fraction by the quotient, that is 4, and put it in the bracket, 1 into 4. Then you have minus here. Then divide 36 by the denominator second fraction, that is 36 divided by 36 is 1. Quotient is 1. Now multiply the numerator of the second fraction by the quotient, that is 1. So 7 into 1, put it in the bracket. Then you have plus here. Divide 36 by the denominator of the third fraction and see what is the quotient you are going to get. 12 3 times 36, 3 is the quotient. Multiply the numerator of the third fraction by the quotient, that is 3. 1 into 3, put it in the bracket. Now let us simplify. 1 into 4 is 4, minus 7 into 1 is 7, 1 into 3 is 3, whole divided by 36. Now let us add the positive integer, plus 4 plus 3 plus 7. Now you have minus 7, whole divided by 36. Minus 7 plus 7 get cancelled, you will get 0. 0 divided by 36. So you will get 0 as the answer. Remainder is 0. So if the remainder is 0, then x minus 1 over 3 becomes the factor of the given polynomial. Therefore, x minus 1 by 3 is a second factor of x square minus 7 over 12x plus 1 over 12 my factor theorem. But we are supposed to find the factors of the given expression, and this expression is obtained by taking 12 as the common factor. Now let us find the factors of the given expression. Now what we have to do? So we have to multiply this polynomial by 12 and also factors by 12. Now 12x square minus 7x plus 12 is the given polynomial. So we got the factors, that is x minus 1 over 4, x minus 1 over 3, multiplying this by 12. So equilibrium is maintained. So 12 into, we can write x as x over 1 minus 1 over 4, put it in the bracket, again open the bracket, x you can write x over 1 and minus 1 over 3, put it in the bracket. Now LCM of 1 and 4 is 4. Now divide 4 by 1, you will get 4 as the quotient, multiply x by 4, then you have minus here. Again divide 4 by 4, you will get 1 as the quotient, 1 into 1, put it in the bracket. Then LCM of 1 and 3 is 3, divide 3 by 1, you will get 3 as the quotient, multiply x by 3, then minus. Divide 3 by 3, you will get 1 as the quotient, multiply 1 by 1. Let us simplify. 12 as it is, 4 into x, 4x, minus 1 into 1, minus 1, then x into 3 is 3x, minus 1 into 1 is 1, all divided by 12. See, we can divide 12 and 12 by cancellation, 12 1 times, 12 1 times. So therefore 12x square minus 7x plus 12 equal to 4x minus 1, into 3x minus 1. Therefore, factors are 4x minus 1 and 3x minus 1.